need to understand positive definite functions and quadratic functions. So a positive definite function takes an element from some vector space and gives us something in R+. That is, non-negative values, real values. So basically, a positive definite function satisfies these two properties. The function of x is greater than or equal to 0 for all x. The function of x is equal to 0 if and only if x is equal to 0. Now, if you remember, these are actually two properties associated with a norm. So a norm actually satisfies the definition of a positive definite function, but a norm is not the only thing. So notice that here we don't have a triangle inequality to solve or to worry about. So this is actually simpler than a norm. In general, we'll also often want the monotonicity property. That is, x1 in norm is less than, if x1 in norm is less than or equal to x2 in norm, then v of x1 is less than or equal to v of x2. So if I start off with a larger x, I get a larger v, basically. So here's an example of a positive definite function. Notice that for every element of x, so this in this case is an x in R4, 4 dimensions, okay? And so if I notice each of these terms is non-negative, okay? So this one may not look obvious, but if you have an exponential function, e to the 0 is 1, and so we subtract 1, we still get something non-negative. So each of these terms is in fact 0 when x is 0, when the x component is 0. And so I can show that I will never get a negative value for any x1, x2, x3, or x4, and whenever each of these elements is 0, the corresponding term is 0. And so I have 0 if and only if all of the elements of x are 0, and so forth. So we see that this is indeed a positive definite function. Now, we can also talk about something called a locally positive definite function. For example, v of x is between 1 and, is 1 minus cosine of x, and it has this plot. Okay, and so between minus 3/2 and 3/2, I get this nice function, and it acts just like a positive definite function, but only in this restricted domain. So we remember the function itself eventually repeats. It's periodic, right? So in terms of scalar functions, these are examples of possible positive definite functions. The main thing is that it never goes negative. Okay, so here, for example, I have a discontinuous value at 0. Here I have a continuous value at 0. I can do it either way.